I can share my screen. I'll do that. Um, today we'll be looking at immunization, basically immunization program in Nigeria, and then the cold chain and VPDs, that is vaccine preventable diseases. Just how these go hand in hand. So we'll just look at it under this following outline, though I've made a few changes to what is on the slide, but this is all we'll be looking at. So public health interventions are usually cost effective but with great public health impact. I know this is misunderstood in many quarters. They just think that because we say public health interventions are cost effective means that they are cheap. No, they might not necessarily be cheap now, but in the long run, they are cost effective compared to the cost, the economic loss, and all the other things that might happen. Okay, just take for example, like in the case of immunization, let's say immunizing for measles. Imagine providing a vaccine, let's say in a country like ours, they say usually children make like 30% of any population or thereabout, you know, or women and children actually make up 1/3 of any population, of our own population. So let's say you are providing a vaccine for, say, 1 million children or 2 million children. That is a lot compared to, say, maybe a case of measles comes into your facility, or even when there's an epidemic. Let's just say maybe you have 100, 200 cases. Or 200 cases coming into your clinic. So if you compare it, providing vaccine for 1 million children and just maybe treating cases of measles of, say, about 100 children, you know that obviously that is the public health intervention actually looks more expensive. But if you look at it in the long run, imagine the morbidities that could be averted if you had to convert it into monetary terms. And then imagine, the other maybe times that could be lost treating and other resources that could be put into the diseases when they occur in those millions of children. You find out that at the end of the day, that of public health is more cost effective. So that should not be misunderstood for being cheap. So immunization is one of the 21st century achievements in public health. It's along with many others, 20th century, sorry. And vaccination is not synonymous to immunization, and we must also take note of that. So when you are talking of vaccination is actually the act of administering the vaccine. And the fact that you administered a vaccine or vaccinated does not mean that the individual is immunized. You begin to talk of immunization if the immunization is taken up and then the individual responds appropriately to the agent being given. Then you now say the individual has been immunized. A vaccine, when given, may or may not produce immunity, like I've explained. So immunization is a process whereby a person is made immune or resistant to an infectious disease, typically by the administration of a vaccine or exposure to the disease. That is if it's naturally acquired immunity. Then vaccines or exposure stimulates the body's own immune system to protect the person against subsequent infection or disease. So it is a process by which individual's immune system becomes fortified against an agent, which is known as an immunogen. And when the immune system is exposed to molecules of the immunogen, it will orchestrate an immune response and will also develop ability to quickly and effectively respond to subsequent encounter or exposures because of immunological memory. So once an individual has been exposed to an immunogen, which could be the vaccine being introduced, or even natural exposure to a disease-causing agent, the individual responds, and in responding, some memory is also produced such that when the individual is exposed the next time, the kind of response is quicker and is also exaggerated, like is greater than one it would have been if it was just for the first time. So what is immunity? The term immunity is defined as resistance offered by the host against microorganisms or any given foreign agent. So we should realize the difference between the two: immunization, immunity. Immunization is a process, while immunity is the host, is the resistance offered by the host. So just a brief history, but I'll try not to bug us too much with that. But then it had started a long time ago. It's not just during the time of Edward Jenner. It actually started long in the 17th century when Buddhist monks drank snake venoms. And also there has been history of variolation with cowpox scabs in China, in Turkey, and Africa, even long before, almost a century, even before Edward Jenner's demonstration of variolation occurred in the West. And in 1798, smallpox vaccine was developed. This is worthy of note. While in 1979, smallpox was eradicated. Remember what we talked about: the difference between eradication, elimination, and extinction, as well as control. In 1897 and 1904, Louis Pasteur did something on live attenuated cholera vaccine and inactivated anthrax vaccine in humans. So I have a timeline here. I hope it opens since I'm online. Okay, just to show us a quick timeline on how vaccine so it's a lot. So maybe later on we can go through it ourselves. So it's a long list, right? From smallpox, which was the first vaccine to be described. You know, so we can just go through it on our own later, so that I don't bug us too much with this. Okay, so we move on. But when you're talking about arms of immunity, which means our immune system, what are the arms? We know that there's the innate one, and then there's the adaptive one. The innate one is fast in action, utilizing. Sorry, please, just a minute. So the innate immunity is fast in action, utilizing pre-existing components to combat an infection. It's limited and has specificity and diversity. It provides pathogen-specific long lasting immunity, and there's no specific memory for the pathogen. Sorry about that. Then includes various cell types, including macrophages, dendritic cells, neutrophils, eosinophils, natural killer cells. Response immediately to an infection is actually the first response to any infection. It can be mechanical or chemical assault, which disturbs tissue homeostasis, and recognizes a large variety of microbes because it is non-specific. So it recognizes a large variety of microorganisms. So sorry, I think the other one I wasn't able to save it. Talking about the adaptive, that one, there are two arms to it. There is the cell-mediated, and then there is the humoral. The cell-mediated, we talk about the T cells and the B cells in that group. And then for the, sorry, what am I saying now? For the humoral, T cells, B cells, because it has to do with production of, that is B cells for the humoral and T cells for the cell-mediated in the adaptive immunity. Sorry, I hope we got that. Two arms of immunity, innate and adaptive. Innate, we've talked about it, like is the first barrier. It can be anatomical or physiological. We talked about the cells, like the natural killer cells, the eosinophils, neutrophils, dendritic cells, macrophages. Then we're talking about the adaptive. Also has two arms, the cell-mediated and then the humoral. Cell-mediated T cells, humoral B cells. Then when you are talking about types of immunization now we are talking about like the process which this resistance is being developed now. It can be in two ways. It can either be passive or active. And under each of these headings, group, we have subgroup of either they are natural or artificial. So types of immunization can be passive or active. So for the passive, this is where pre-synthesized elements of the immune system, such as antibody, are transferred to a person, so that the body does not need to produce this element itself. This method of immunization begins to work quickly because they are preformed, but however, it is short-lived and the antibodies are naturally broken down. So like we said, it can be natural or artificial. For the physiological or natural passive immunization, it occurs when antibodies, an example is when antibody is transferred from mother to child transplacentally to protect the child. This happens in case of measles, malaria, and even HIV/AIDS. And the antibody is usually of the IgG type. Then artificial passive immunization. This is normally administered by injection, and it is used if there is a recent outbreak of a particular disease or as an emergency treatment for toxicity. E.g. anti-tetanus serum or rabies immunoglobulin. So these are already formed antibodies, and so when given, they'll go to work. And this is best used during outbreaks, or like in the case of rabies, if you are not certain of the status of the individual, whether the person has been immunized or not, you will give both active and passive immunization. So for active immunization, it can also be natural or artificial. So for the active natural, occurs when a person comes in contact with a microbe. The immune system will eventually create antibodies and other defenses against the microbe. So such that it creates that memory, such that the next time the immune response against this microbe, it can be more efficient by being quick and also in larger quantity because of the stored memory. For the active artificial, this is where the microbe or parts of the microbe are injected into the person to stimulate the immune system to produce antibodies against the microbe. This is what we refer actually as vaccination, and this is what is on the immunization schedule. what we get is actually active artificial immunization, or artificial active immunization, sorry. Okay. So vaccine preventable diseases.